Assalamu alaikum dear students. We are discussing derivatives of trigonometric function. In previous lecture we discussed the derivative of sine and cos. Today we will be discussing derivative of tan x and cot x. Let f of x equals to tan x. First one. Then we have to find f dash of x, that is dy by df by dx. Or if we put here y equals to tan x, then we have to find dy by dx. We know that derivative at a point is limit h tends to 0. If it exists, is limit h tends to 0 f of x plus h minus f of x upon h, because a derivative is actually if limit x tends to c, f of x minus f of c upon x minus c exists. Now limit exists means right limit equals to left limit. That is why here we say that when derivative exists, derivative is actually equals to either right limit, right derivative, or left derivative. That is why here we are taking the right derivative. Now f of x plus h is tan x plus h. F of x is tan x, which is limit h tends to 0 tan x plus h minus tan x upon h. Now we can write this tan as sin x plus h upon cos x plus h minus sin x by cos x. Now by cross multiplication it is sin x plus h cos x minus sin x into cos x plus h upon cos x plus h. Now sin a cos b minus cos a sin b is sin a minus b, which is limit h tends to 0 sin x plus h is here a minus x is b upon cos x plus h. Now x cancels, it is simply sin h. Now here cos x is independent of h, so this means that in terms of h it is constant. It comes out from this limit. It is 1 upon cos x upon limit h tends to 0 sin h by h into cos x plus h. Now limit of product equals to product of limit, that is limit h tends to 0 sin h upon h into limit h tends to 0 1 upon cos x plus h. Now limit h tends to 0 sin h upon h is standard limit, that is 1. Now 1 upon cos x plus h can be written as, in terms of limit, it is 1 upon cos x plus 0, that is 1 upon cos. So it is 1 upon cos into 1 upon cos x, that is 1 upon cos square x, that is sec square x. So this means that the differentiation or the derivative of tan x is sec square x. Similarly, in the same way, we can prove that derivative of cot is minus cosec square x, derivative of sec is sec x tan x, and differentiation or derivative of cosec is minus cosec x cot x. So in this way you can find or you can use the derivatives of these trigonometric functions, 6 main trigonometric functions. Now we will discuss the derivative of another type of function, that is exponential function, which is of the form of e raised to power x. We know that right derivative is limit h tends to 0 f of x plus h minus f of x upon h at a point x. Now substituting these values, f of x is e raised to power x, which implies that f of x plus h is e raised to power x plus h minus e raised to power x upon h. Now e raised to power x plus h can be written as e raised to power x into e raised to power h, taking e raised to power x common. Now e raised to power x is independent of h, so in terms of h it is constant, hence it comes out from this limit. It is limit h tends to 0 e raised to power h minus 1 upon h. Again this is standard limit and you know its value is 1, so this means that here right derivative, that is or f dash of x, is e raised to power x. Similarly you can put this L f dash of x as limit h tends to 0 f of x minus h minus f of x upon h, and in the same way the value of this L f dash of x is e raised to power x. So right derivative equals to left derivative, which implies the derivative exists, hence the derivative or f dash of x of e raised to power x is simply e of x. So this means that derivative of e raised to power x is e raised to power x. So in this way we completed the derivatives of some standard functions. Inshallah, from tomorrow onwards we will discuss the exercise related to this derivative. So thank you.